Welcome back. During this video we will discuss the challenge in the field of the water systems. Some professors already told you about the river, coastal and the ocean systems. I had an interview with Professor Steve about the challenges he is facing in the water systems. I welcome Professor Steve in the studio. He is a well-known professor in this field. Professor Steve, you and your colleagues of the hydraulic department explained some basics of the variety of water systems that are Earth hosts: rivers, coasts and oceans. I am sure you are only scratching the surface of our knowledge, right?
Yes, indeed. This MOOC should be considered as a wide introduction to our understanding of natural water systems and the role of our climate in their behavior.
Would you consider to share your and your colleagues' knowledge in more detail?
We certainly are motivated to do so, especially seeing the large number of students following this MOOC. We can offer more in-depth courses on each of the water systems, and in fact we're planning to do so. We want to take this all a step further, offer our regular courses not as a single topic, but in mutual coherence, where students can assure earning master credits that will eventually build up to a complete Master of Science diploma.
What then would be the more in-depth knowledge do you envisage to teach?
Well, we are an engineering university, so we value a lot to have not only a qualitative, but also, and foremost, a quantitative understanding. We wish to give students knowledge, rule of thumb tools, and advanced modeling tools to understand the behavior of natural water systems.
So this MOOC is addressing water and climate. What major challenges do you see in the context for water systems?
Both rivers, coasts and oceans have been very much influenced by the climate and its changes. While rivers and coasts mainly respond to climate change, the oceans play a pivotal role in our climate. Oceans have such a large water body that they play a role in the heat balance. We envisage to provide more insight into the role of oceans, and regarding rivers and coasts, we would focus on climate change impacts. Our river systems, such as the Rhine River system, may change from a snow-dominated to a rainfall-dominated system. This will have its impact on the discharge regimes and have consequences on the river system and even on the coast. Sea level rise has historically its impact on coasts and will do so forever. We have suggested some of the impacts, but realize that the impacts are compound, and we will be able to highlight these impacts.
The Department of Hydraulic Engineering at Delft University of Technology is conducting quite a lot of research on the field of water systems. So let's now have a look at Caroline Katzma, one of our associate professors at this university. She is doing research in the field of ocean systems.
My name is Caroline Katzman. I'm an associate professor at environmental fluid mechanics, and my research is on physical oceanography. In environmental fluid mechanics we work on rivers, on sediment transport, on coastal oceanography, and I'm one of the oceanographers looking more into circulation in deep waters. As you've seen in the MOOC, the circulation in the ocean is driven by the winds at the surface and by density differences, so differences in temperature and in salinity. And this so-called thermohaline circulation is the topic of my research. I'm looking at circulation in the North Atlantic Ocean because the North Atlantic is a key region for the thermohaline circulation. It is a region where there's a northward surface transport of warm waters, and these waters they sink in the North Atlantic and then they return at depth. And this circulation transports an enormous amount of heat and is important for climate. Not only to determine the temperature in our regions, but also it is important for sea level. And for the Netherlands, that's an important aspect. The fact that we have a thermohaline circulation now in the North Atlantic with northward surface transport and southward deep transport means that sea level is relatively low. And what we are thinking about and worried about a bit is how this circulation is going to change in a warming climate. The waters now in the North Atlantic get very dense because they get very cold and very salty, and they are dense enough to sink. But you can imagine that in a warming climate, the ocean gets warmer and the ocean also gets fresher because of sea ice melt and increased precipitation. So we think that the waters are not going to be as dense as they are now in the future, in the coming century. And that could have consequences for the whole sinking process and for the thermohaline circulation in the Atlantic and hence for the climate. And there is a consequence for sea level as well. As I said, there's low sea level now in the North Atlantic because of the circulation. If the circulation would weaken, the sea level would tilt up again in our region and would affect the local sea level here. So what we are studying here in the group is how these dense water masses, where they are formed in the North Atlantic, where they sink, and how this whole sinking process will be affected by changes in the environment, so by warming climate, for example. And the way we do it is we look at numerical models, so computer models of the ocean circulation, and we use both global models that try to simulate the circulation as realistically as possible and analyze these, but we also have very highly idealized regional models where we really study the processes and try to understand what's happening and what sets the conditions that you can have these deep convection events and mixing of water masses and sinking of water masses, and how these things change when you change the atmosphere or change the currents in the ocean or change the salinity of the ocean. And all that is, on one hand, to understand what's going on in the North Atlantic, but also to see the impacts and thinking about sea level rise and coastal defense.
So now you have seen what kind of challenges our water system researchers and our society as a whole are facing. In the next video, we will discuss climate and climate change challenges that our researchers are coping with.